Hello, uh, welcome to this talk. My name is Dmitry Soshnikov, and today I'm going to talk about non-traditional usage of Microsoft Azure Cloud. And what do I mean traditional? Well, normally we would use the cloud for some kind of enterprise applications. Uh, People would not use it, for example, for personal websites because that is not always practical. However, what I am going to talk to you about today is the usage of cloud for my hobby, for my personal project, and we will see that that is in fact pretty practical. So a few words about myself. I work at Microsoft as cloud developer advocate, which means that I give talks at conferences, I write content, and I also take feedback back to our product teams. So in case you don't like something about Microsoft Azure and you want to report a problem, you know whom to contact. I used to work as software developer engineer on AI and ML projects with big European companies. And I also work with a lot of academic institutions and even teach at a couple of universities in Moscow, where I live. In addition to that, what I like to do some projects in between art and technology. It happens that my daughter goes to art school, and I want her also to learn mathematics and computer science. So I always try to look for a project somewhere in between computer science and art. And a few things that I do, you can see on this picture. Uh, First of all, the most important thing that I want to tell you about the cloud, and I think that people should understand, is that a cloud is the great collection of building blocks from which you can build your project. Uh, Normally, you don't have to think about hardware. You don't have to think about where your code will run. You just have to think like what kind of components you can put together to make things work. And that is really good way to view the cloud, because there are some really high level services in the cloud that you can use to perform whatever you need. And we will see a couple of examples today. So the first thing that I will start with is so-called cognitive portrait. That is the technique that you can use to create nice portraits like this one here on the right for your friends. That's what I did, for example, during the last New Year. I took the photographs of my friends. I blended all the photographs together, creating those kind of images, and printed out calendars for them. Uh, Here on this slide, you can see the portrait of me and my daughter. I took something like 7 photographs of me, 7 photographs of her, and blended all them together. Actually, the code to do that is available on GitHub, so you may want to check that sometime if you want to try it. The main idea here is that we can extract automatically using a cloud service called Face API. We can automatically extract facial landmarks, the key points on the face from the photograph. And this Face API can in fact extract quite a lot of points, something like 29 different points. Which you can see here on this picture. By the way, Face API can do much more than that. Face API is the collection of pre-trained neural network models which live in the cloud, and you can use it to, for example, identify if 2 photographs belong to the same person, or to identify emotions of people, many interesting things which are definitely very applicable in the business scenarios as well. But for us in this simple scenario, what we need is just those facial landmarks, key points on the face. And once we know them, we can apply a fine transformation to our picture. So suppose we have the face located somewhere in the picture, like not in the center, but somewhere. And what we need to do, we need to align it in such a way that the face is exactly in the right position. And for that, for a fine transformation, we need 3 key points. And we can take, for example, 2 key points as the eye pupils, and then some third key point, like, for example, the middle of the mouth here, and align the photograph in such a way that those 3 points occupy exactly specified, predefined positions. And luckily, if we do this programming in Python, we have the power of OpenCV library at our disposal. And OpenCV can do like everything you can imagine with pictures, and fine transformation is included. So we just need to call a couple of functions in OpenCV, get a fine transform to get the metrics of the transformation, and then warp fine to actually perform the transformation on our image. So to show you how it works, I will just briefly show the Jupyter notebook. First of all, to mention, in order to use Face API, you would need access to Microsoft Azure. And in case you don't have access, you can get the free trial access. If you are a student, you can get a free student account for 1 year, which will include those pre-trained models as well. So once you do that, you need to set up the special cognitive service object in your cloud subscription, and it will give you a special key and the endpoint. Those two things you need to access the service programmatically. And then actually extracting the key points is the matter of calling one function. Here is an example. I take the URL of the picture somewhere on the internet, and I call one function, detect with URL. And what I get as the result, I get the dictionary of all the coordinates. Also, like if I want the age of a person or emotions, I can get them using the same function call pretty much. Here I ask to return face landmarks, but I can return also some other information. Then what we can do, we can take the bunch of photographs, which I have already put in one directory, the pictures of Bill Gates. I like to experiment with them. And here, as you can see, the example, one picture and red dots indicate all the extracted facial landmarks, which kind of proves that this works. And when we have the bunch of photographs, what we can do, here is the like first 5 photographs from the collection that I have. You see they are pretty diverse, but after we apply a fine transformation, we end up with aligned images. You see all of them are aligned in such a way that face is at the same position. So now we only need to merge them together, and when we merge them together, we get the portrait. So that's pretty easy technique, and we have already used cloud to do this because we have called pre-trained Face API model in the cloud to get facial landmarks. You can, by the way, do more interesting things like aligning photographs in any way you like, because once you get the coordinates, you can play with that and create some kind of nice and interesting images like this. But what's more interesting is to do something interactive around this idea. And once there was an open call in one of the museums in Moscow called the Electro Museum. And I proposed to do the interactive exhibit, which is a kind of screen, and people walking by the screen can pause for a second. It will take the picture automatically, and then it will create the mixed portrait of the visitor of the exhibition. So that is kind of how it works. You can see the actual picture of the exhibit on the left. And what do we need to make this work? Well, you can see here you have the first prototype. It takes picture every second, and it's kind of shows you that it can blend the faces nicely. When me and my daughter, we kind of stepped in front of the camera for a few minutes, and you can see how the face nicely blends from one face to another. So what do you need to implement this solution? Well, first of all, you need some kind of client which will take the picture. And to do that, you can use like pretty much that can be any technology. But the good idea is to be able to detect face locally. Because otherwise, if you send like every 2 seconds the photograph to the cloud, that will take a lot of traffic. And it will also eat up our cloud subscription, because this service, it gives quite a lot of free the free tier can give you the access for free to quite a lot of photographs, but still after that you would have to pay. So it makes sense to only send the picture to the cloud if there is a face on it. And luckily, UWP applications, they have built-in functionality for detecting faces. So that is a very good candidate for building client application. And you can run universal Windows applications on both like Windows-based computers. You can also run them on Raspberry Pi on a very compact board. So that gives you a lot of flexibility on how you can build your client application. And then in terms of the cloud, it makes sense to do all the processing in the cloud. Why? Because it's nice to be able to collect the incoming stream of photographs. For exhibition organizers, it's nice because they can estimate the age population of the visitors, and they can do some additional processing on the back end. So to do that, we need some kind of code to run in the cloud as well. And normally what you would do, you would kind of spin up the virtual machine or you would buy a hosting. But in the cloud, there are higher level building blocks. There is, for example, something called Azure Functions, which is called serverless application, because it's a way to run a piece of code when you need without worrying about underlying compute. So you can say, here is my Python function. I want to run it whenever somebody places the image in the storage or whenever somebody calls it via HTTP endpoint. And it will automatically run it. If the underlying virtual machine is not running, it will power it up or it will find some resource to run it on. And the good thing is that you pay only for the calls, for the number of calls and for the actual time it took to execute your code, but not when it's idle. So, for example, if no one visits the exhibition at night, you are not paying anything for that. And you don't need to think about shutting down virtual machine, about scalability and all other things. It is all already taken care of. So Azure Functions can take our incoming photograph, put it somewhere in the storage, and return us the photograph which has already been composed together. And this architecture also gives you a great opportunity, for example, to run another exhibit in the different museum and blend together pictures of people from different museums, which is kind of nice. So let's see a little bit in more detail how this is organized. So first of all, let's start with UWP application, and I will just show you briefly how it works. Here you can see that this application detects the face, does the countdown, and takes the picture. You can see the picture here below. And when the new face appears, again, it does the countdown and takes the picture. Right now, it doesn't do anything useful. It doesn't send it to the cloud yet because we don't have the backend. It's just the client application. So to show you really briefly a little bit of the code, the local face detection is used here. So first of all, the way it works, when we start the application, we call the init function, and init function initializes this face detector. So we provide some of the setup, like how long should we wait before firing it if the face is present, and so on. Once this face is detected, it basically calls the function, it fires the event. You need to transfer it to the UI thread if you want to draw something, and we want to draw the border around the face, so we transfer it to the thread and we draw the border, and that's how it works pretty much. And I think that's should be sufficient to understand the basic idea that we do the processing locally. And then now let's talk about Azure Functions. So Azure Functions are actually a really great functionality of the cloud. And whenever you need to run a piece of code somewhere in the cloud, you should think about Azure Functions. So Azure Functions, they can be written in different programming languages. They support C#. Really nicely, they support C#, but they also support Python and a number of other languages, including the ability to plug in your own. And the way Azure Function works is that you have some input triggers, and triggers is something that make your function run. So for example, when somebody is calling it on the HTTP endpoint, it can be an input trigger. So you can easily create APIs with Azure Functions. You can also create a trigger which runs when you place the object in the storage, in the cloud storage, which is kind of excellent way to do it because think about it. Suppose you need to resize all the photographs that people upload to your website. You can just write an Azure function to do that and forget about it. You don't need to think like how you would run the queue when somebody places the image in the queue. You need to like have a service which resizes them periodically. You just write a piece of code, put it in the cloud, and forget about it. That's really a neat way to do it. Another good way about Azure Functions is that they support bindings. When somebody puts the image in the storage, your function is called with already the object as the parameter. So you don't need to write any additional code to load this object from the storage. The function runtime does it for you. And you can also declare the binding to some third-party resources. Like, for example, if you also need to store information about this image to a table, or you need to do some additional processing, this can be done using output binding. Again, you just return the result, resized picture, and it is automatically placed in the storage. So really, really a good way for you to concentrate only on the business logic of your application. So the way it works is that Azure Function has two main components. First of all, of course, is the actual code for the function. And second is the function.json, which is called binding file, which specifies how to bind this function, what would be the triggers, and how to bind it to some external resources. So this is the simplest result. When you create the empty Azure function, it will create something like this. So this one is HTTP trigger. So it would take the HTTP request as the input parameter and return the HTTP response as the output parameter, and then do some processing in the middle. So in our case, we will use again this HTTP binding, and we will accept incoming image. So what we do here, I will not go into details, but we take this body of the image. We store it into the blob just to keep track of all the incoming images. Then we do the image processing. So we call the cognitive service, and this call happens inside the cloud, so it's going to be very fast. But technically, the call is again just one function, detect with stream. We provided the stream of bytes, and we get back the facial landmarks. So then once we see the face, we apply cognitive transformation to it and store it in another blob file. So we have rotated our image so that the face occupies the good position in the middle. And then we need to create the result. The result, we need to blend 10 last photographs, for example. So we take 10 last photographs again from the blob. We average them. So blending pictures in Python is done very nicely as the average function on the array. And then we encode it as JPEG and store it again in the storage, and we return the URL, which is nice because if the image is stored in the cloud, it's very easy to get it from all applications. Like in UWP application, for example, you just need to specify this URL to your UI element, and it will render the photograph automatically. It will download it from the cloud and render it. So in fact, it turns out to be the easiest way to return. Instead of returning the actual stream of bytes, we return the URL, publicly available URL of the picture. So that is Azure Function. You can develop it locally. You would need to install Azure Function Developer Tools, which is the small SDK that and library which supports this locally. You can run it locally, debug it locally, and once you are ready, you can deploy it to the cloud. And this can be done, of course, like from the command line, or it can be done from Visual Studio Code. Visual Studio Code, by the way, is really great tool to write whatever development project you are doing. So once you publish, it becomes available in the cloud. And the only thing you need to do now is to bind it to our UWP application. And to do it, that's pretty straightforward. So we have the function which takes the photograph here. And once the photograph is taken, we need to do the actual call to the cloud. And call to the cloud, I will put it into a separate function, call cognitive function. And this call cognitive function would essentially invoke the URL of the Azure function. So that is how it works. Asynchronous call, we will do the post request to the Azure function URL. And Azure function URL, we will take, once we deploy it, it will be available for us at the Azure portal, or actually when we deploy from command line, you will see the URL that you can use to call the function. So that's pretty much it. We have this application now working. Let's see how it works. It takes the picture, and then because it's calling the function for the first time, you can expect some delays, because if it's serverless, it means that if it hasn't been used, it warms up. So it takes some time to warm up. So now you see the second and third, like all the rest of the calls are very fast. Like it updates very fast. Takes the photograph, and then it updates. So that's how you can use this Azure Functions to create the nice complex application like this. But you can do even more, because we have all the logic at the back end. We can create different front ends to it, and that is what happened when pandemic started. I put this exhibit into the museum in February 2000. And the museum was closed in the middle of March for COVID pandemic. And then I thought, how can I make this functionality available to people online? And the first idea was to create the chatbot. Chatbot seems like a natural interface. We can ask people to post a photograph, and it will give back the blended photograph of a person with other photographs that other people also have posted. So that is how the bot works. And here we can use another cloud technology, which is called Microsoft Bot Framework. Bot Framework and Bot Service. The idea of so yeah, it will feed into the same overall architecture. So we will have the bot framework working on the back end, and once it receives the photograph from the bot, it will call the same Azure function. Absolutely the same Azure function. You don't have to make any changes to it. And then we can also, instead of we can use chatbots through channels like Telegram, for example, but we can also use just a web application and take the picture from the camera and upload it and pretty much do the same thing. So the beauty of bot framework and bot service is the following. Normally, you have very different, many bot channels. Like you can create chatbots in Telegram, you can create chatbots in Facebook, in Slack, in Teams, and so on. And if you want to create different chatbots exposing your functionality in different channels, you would need to use different SDKs. So you will end up essentially writing 10 different code bases for different bots, for different bot channels. Bot framework allows you to write the code just once. So you write your bot as web application, and you ask the cloud to forward the calls like from different channels, from Facebook, from Telegram, from Slack, to this web application. So you write only the logic, and then you can connect it to different channels declaratively, just by saying through web interface, I want this to be available in Telegram. I want this to be available on Facebook, which is really good way to do it. So you can develop this as the application, the web application in Node.js, in C#, in Python, using Bot Builder SDK. And Bot Builder SDK provides some additional abstractions on top of just request response interface. So the simplest chatbot is in fact request response. You take the input string from the user, you process it, and you provide the output. But in many cases, you need something more complex. You need to do dialogues. You need people to fill in the form, to answer, and so on. And to do that, the Bot Builder has different abstractions. In addition to that, Bot framework supports higher level tooling, because normally development of a chatbot, development of dialogues is the job of data analyst and somebody who knows the problem domain. So that's why it's a good idea, instead of asking them to develop the bot in the low level programming languages, we can use higher level graphical tools. And the two similar options include Bot Framework Composer, which is the graphical tool which allows you to draw the dialog flow, and it will then generate the underlying C# application. And another approach is Power Virtual Agents, which is like pretty similar, graphical language. So if you want to read more about our bot platform, I have the extensive blog post on this topic. And in this blog, you can see the overview together with some code examples. So if you want to try it, this bot is available in Telegram using PeopleBlender bot name. So you can add it if you have Telegram and try to send your picture and see what you get in return. So this project, in fact, provides a really good overview of different cloud components. And I have some links here on the slide, again, if you want to read more about them. So we talked about we haven't talked about web applications so much, but it uses web applications. We talked about bot framework, about cognitive services, about Azure functions, and also a little bit about storage and blobs, but not much. We have seen how easy it is to use them from Python. And finally, if you want to see again how this technology works, you can also do it without bots. You can go to this address, easyfi.net/peopleblend, and it will open the web page. You would need to say, I wanted to access my webcam, and it will take a photograph from you and blend it together with other people. So if you are watching this talk right now, I definitely suggest that after this talk, you go and you try to do that, and we will have the blended portrait of the conference visitor. Finally, another thing that I tried to experiment with is creating drawings using artificial intelligence completely. So ideally, we want neural network to be able to produce some piece of art by itself. And in fact, it can be done. There is the technology called generative adversarial network, which is trained on pictures, on normal pictures. And the idea of this neural network is the following. We have two neural networks. One is called generator, and the role of generator is to produce the piece of art from a random vector. So we give it a random set of numbers, and for each set of numbers, it gives us a new painting. However, this sounds like too good to be true. We need to train this neural network. And to train it, we use the clever trick of another neural network called discriminator, which we train to distinguish between artificial painting and real painting done by people, by human being. And when generator does a poor job, the discriminator can easily distinguish between this picture and the real picture. And so discriminator can be trained. It becomes it starts to distinguish very well, and then we train those two networks together. We train those two and say, please pretend that this is a real painting. And by training two networks, it also trains the generator. It's a very clever thing, but it requires a lot of computational resources. So to do it in the cloud, you can use Azure Machine Learning. For all machine learning tasks, there is one stop to go in the cloud called Azure Machine Learning. And Azure Machine Learning provides a lot of different components to your machine learning tasks, like powerful compute. You can run notebooks, Jupyter notebooks there in a simple way, but you can also schedule experiments on the cluster and so on. For example, this experiment, which produced the pictures like I have shown you earlier, it took 11 hours to complete, and definitely it's not worth sitting in front of the computer and waiting, so we can schedule the experiment and just collect the results later. So the way this looks, Azure Machine Learning, you have the control panel like this, and you can go and see, here's, for example, I have the list of my experiments. And here is my experiment called Keragan for generative adversarial networks. And here are two experiments for portraits and for flowers. You see 11 hours each. And then I can check the outputs. And in the outputs, I have the pictures, I can see how it was trained. So this is the initial pictures that network generated. They are quite pointless. Then it starts trying to do something. And then at the end of the training, you can finally see something more meaningful. Those are trained on portraits. So you can see there are kind of artificial faces here. So I will not go into detail here. You can read my blog post here, easyfi.net/azmlgun, which describes this process in detail. And also, if you want to learn about Azure Machine Learning in more detail, I have the tutorial available on GitHub at this address. So that is it. I have described you a number of projects in the cloud that helped me realize my creative potential, and I hope it outlines different kind of possible ways you can use cloud to solve your tasks. And even though this example was non-traditional in the sense that it's not an enterprise application, definitely all the same technologies are very well applied in all business scenarios as well. If you want to check out any links available to you in this application, this presentation is available at this URL, easyfi.net/dex/infobip. And if you have any further questions or comments, I would like you to, I would be really glad to answer. And my contact information is available at my personal website. Thank you so much, and have a great rest of the conference.